example question says, find the tangent line or tangent lines to the given curve at point 3 and 2. So as you can see, the curve is written implicitly. It means that you have a combination of x and y's and not y, not x. None of them are isolated on one side. So we have implicit relation. We're going to apply implicit differentiation. To calculate the derivative of each term, we're going to take the differential of each term with respect to x. The derivative of x squared with respect to x is 2x. The derivative of x times y, we are applying the product rule. Remember, if you have the product of f and g, the derivative is f prime g plus f g prime. We are applying that right here. The derivative of x is 1 times y plus x times the derivative of y. The derivative of y is not equal to 1 because y is a function of x. So the derivative must be present here. Minus the derivative of y to the third with respect to x. Y is a function of x. So we get negative 3y squared times y prime. On the other side, the derivative of constant is 0. So now that we calculated the derivative of each term, we're going to group y prime on one side and factor out y prime, so we can write y prime equals to a combination of x and y's. You have 2x plus y plus xy prime minus 3y squared y prime equal to 0. Keep 2x plus y on one side and then bring these two terms to the other side. We're going to subtract xy prime. That's how you end up with negative xy prime. And we're going to add 2y squared y prime, 3y squared y prime to both sides. So you end up with 3y squared y prime. Now between these two, factor out y prime. You're left with 3y squared minus x. And then if we divide both sides by 3y squared minus x, we get this rational expression which representing y prime or the derivative of the function. Now that you have the derivative of the function, you can easily find the slope of the tangent line. The slope of the tangent line, as we have x equals to 3 and y equals to 2, is equal to. Wherever you see x, you're going to substitute 3, and wherever you see y, you're going to use 2. So you have 2 times 3 plus 2 divided by 3 times y squared. Y is 2. So 3 times 4 minus 3. And once you simplify that, you get 8 divided by 9. So this is the slope of tangent line, which is positive. So we expect the tangent line to be an increasing rate of change. This is a slope of tangent line. The equation of the line is y minus y sub 0, which is 2, equals to m, which is 8 over 9, times x minus x sub 0, which is 3. Distribute 8 over 9 into parentheses, and then add 2 to it, and we get the tangent line to be y equals to 8 over 9 times x minus 2/3. Very good. So this is the graph of this implicit relation, and then the tangent line at point 3 and 2, as you can see, is increasing line because the slope of tangent line is positive. And finally, this is a summary of what we did. We wanted to find the equation of tangent line to the given curve at point 3 and 2. We start taking the implicit differentiation. We applied the product rule and we applied the chain rule. We did a little bit of algebra to simplify, and we have the derivative dy over dx, or y prime, is equal to 2x plus y divided by 3y squared minus x. And since it's given at the point 3 and 2, we just plug in these values to find the slope of tangent line, which is 8 over 9. And finally, the equation of line is y minus y sub 0 equals to m, parentheses x minus x sub 0, and then we distribute 8 over 9 into parentheses, add 2 to both sides, and simplify, and write it nicely as y equals to 8 over 9 times x minus 2/3.